Okay, good evening, everybody. Welcome to our monthly meeting with the Fort Worth Astronomical Society. I'm going to be your host tonight. I hope you like my voice, because you're going to be hearing it a lot, because I do a lot of things in it. So Bruce and his wife are out on a trip, and so I'm doing the meeting tonight. Next slide. So tonight that have come, not club members, but just visitors that have come out to check us out. Bob?
I'm going to get my steps in tonight.
Well, tell us a little bit about your interest and what brought you to the club.
Yeah, so my name is Uzi. You just call me Uzi. I saw your post on Facebook, and I went to one of your start parties, so I just kind of been introduced to you guys for like 3 weeks now. It's pretty cool, you know, that there's a whole community here in Fort Worth interested in astronomy, and I've been trying to dip my toes in that for like a year. So yeah, good to meet you all.
Awesome. Welcome.
My boy Tom here, really nice.
Any other visitors?
Did you go to the Tandy? Is that where you went? That's John McRae's bit.
Okay. Next slide. So we've got 4 new members since our last club meeting. Is Eric Wassenmiller here? Eric Wassenmiller, or Corey Morris, or Jeffrey Wayne Robinson, or Natalie Bruce. Okay, well, wherever you are, welcome to the club. Next slide. Okay, so a little bit about the club. We were founded in 1949. As of right now, we have 350 individual members, and there's a wide range of experience with all of our club members. It's very diverse, lots of things. We're all willing to help, all willing to teach, and we're a nonprofit organization. And so this information right here you can read on next slide. Resources. We've got a dark site. It's 2 hours west of here in Rising Star. It's being developed. We've got Thompson Observatory, which is in Keene. We've got club telescopes and membership handbook and online resources. So a lot of places to get information and do things. So next slide. And here's what I was going for. So Fort Worth Astro is our website. We've got our Facebook page. That's about to come alive. Thank you, Christian. And our YouTube channel. And we've got 2 groups IO, our main groups IO group, and then the astrophotography special interest group. Next slide. I would like to actually ask Cy to come up here for something a little special tonight. That's cute.
So as you may or may not know, one of our club members had his picture published on the Reflector magazine. Sean, come on down. You got the front page of the Reflector magazine, the quarterly edition for September 2024. So we thought we'd commemorate that. And here you go. Show it to everybody. So it's got the front page. And then the third page had a little acknowledgement of what he all did. So it says, Sean Paul, astrophotographer, first published image. Congratulations. Can we have somebody take a picture of him so we can get it in prime focus? I will. Yeah. And if you want to just leave it up here afterwards, I'll look at it. So, yeah, but take a picture first. Yeah.
Oh, yeah. Beautiful. Oh, one more.
Sure, get his face in there. All right.
Oh, yeah, right, yeah, there you go.
It's just such a gorgeous picture.
Next slide. So who we have for us tonight, a very special guest. He was in the Hubble space program as a program scientist for 2 years. He was the program director for the James Webb Space Telescope. And since I think 2002 until present, he's been a program scientist for the James Webb. So I'll let him tell you the rest, but please welcome Dr. Eric Smith.
Hey, thank you very much for this opportunity to come and talk to you all about the James Webb Space Telescope. And I'm going to attempt to share my screen here. Actually do something with Google Chrome to allow it. Well, I'm back, so let's try this again.
There we go.
And can folks hear me on that end?
Absolutely.
Okay, yeah. Sorry for that. That was a computer permissions error. So I want to emphasize this subtitle for the talk, A New Era of Astronomy for All. And I'll explain what I mean by that. It has meaning both in how we built Webb and how we are using Webb. So first, to address the point about how we built Webb. What you see here is a little graphical representation of where we got major hardware or software contributions that enabled Webb. So it's really an international endeavor. We probably should have a dot down there in South America because we launched from Peru and French Guiana. And all major astronomy missions at NASA really are international missions at this point. Astronomy is a worldwide endeavor, and to study the cosmos, this is a reality now. We have to involve the world in this because the efforts are so ambitious, and we want to harvest the best ideas across the globe to enable advances in astronomy. So why did we build Webb in the first place? Many of you have probably seen this picture. This is a Hubble Deep Field. This is from 2014. One of the things they looked for in the Hubble Deep Field was evidence that they could see the first stars and galaxies. And almost everything you see here in this image, except for those few things with the diffraction spikes, are of course galaxies. And all of them show signatures of many epochs of stellar evolution. So none of these things are the first galaxies. Hubble, the most amazing telescope that humanity had ever built, was unable to find the first stars and galaxies. And so this is now near the end of the 1990s. We recognized if we wanted to do this, we needed to build a different kind of telescope. And so we're going to go just do a brief physics lesson on what we need from that telescope. So if we look at the spectral energy distribution of a galaxy, that is, as a function of wavelength, where does most of the energy come out? And so here you see if you have something that's peaking in the optical part of the spectrum, so a star emitting most of its light in the visible at a redshift of 0, z of 0 in the local universe, what if we now put that object in the Hubble flow? So as it's moving away from us, the effective redshift moves that peak of its radiation to the red. And so at a redshift of 3, that peak has now moved into the infrared part of the spectrum. And if we move it out to a redshift of 10, it is now starting to go into what we call the mid-infrared part of the spectrum. So one of the reasons Hubble was unable to see these first stars and galaxies is just because of redshift was moving that peak of light from the optical, where Hubble is optimized for, into the infrared. So that tells us we needed to have an infrared optimized telescope if we wanted to search for these most distant objects. Now, the effect of the universe expanding is also realized in that this, not only does the redshift, does the wavelength redshifted, but it is diminished in brightness. So while the universe is shifting it to the red, it's decreasing the brightness that we detect here. And so if you can see on this graph, and that same object at a redshift of 0, if it's at a redshift of 10, is 10,000 times fainter. So if we want to look for an object, the very earliest epochs of the universe, we need an infrared optimized telescope that is bigger than the Hubble Space Telescope. And this is what tells us what we needed to do for that next generation of space telescopes. So if you have an infrared telescope, what else does that get you? Now we know that an object whose black body temperature is about 3,000 degrees, so a cool star, an M-type star, is going to have its peak around a micron or so. But as we look at cooler objects, their peak of radiation moves farther into the infrared, and so you're able to study cooler and cooler objects. So we'll talk about this later when we look at how astronomers are using Webb to study star formation in our own galaxy by looking at cooler regions of space. What else do we get from infrared light versus visible light? This is one of my favorite pictures where, imagine you're a distant person on an exoplanet and you're somehow able to take a picture of life on Earth, and you see these two different kinds of creatures here, and you wonder what the differences in them are. And if you look at them in visible, well, they're obviously morphologically different, but if you look at them in infrared light, you can also tell there's something very different about them. Meerkats warm-blooded, crocodiles cold-blooded. So infrared light also tells us something about what's going on inside the objects we're looking at. Now, many of you know about Hubble, of course. It has the characteristics here on the screen. Webb is very different. It's a naked telescope. We'll talk more about why it's shaped the way it is, but you can see that it has very different parameters. And this was some of the challenge in building Webb, is that we were building a telescope unlike any telescope in space that had gone before us. So let's talk a little bit about those engineering challenges that we faced when we were putting Webb together. So this is a little bit seeing the end of the story before we talk about the beginning. These are some beautiful pictures at the left. The leftmost picture there is when the mirror was at the Goddard Space Flight Center during its final completion. And then the two pictures at the right are when the entire spacecraft was assembled at the Northrop Grumman facility just south of the LAX airport in Los Angeles. And that picture on the bottom right is the most deployed the telescope ever was on Earth. And you can see that it is not fully deployed. So the first time this telescope was ever completely deployed successfully was when it was on orbit a million miles from Earth. So some of the technical challenges, right? So we had to build this very large infrared optimized telescope. And because it was very large, it was bigger than any rocket fairing that we currently have. And so that picture on the upper left shows an outline of a rocket fairing and the size of the deployed Webb telescope. So obviously we have to fit that whole thing into the rocket fairing before we can launch it. So that means we have a lot of challenges, just mechanical challenges in not only deploying once we're in space, but folding it up. And so we had to do many tests of folding and unfolding to make sure we could do it on orbit. The picture in the middle that says BE mirror segments, beryllium mirror segments, we wanted to put most of our mass in science instruments and telescope optics. We didn't want to have it in telescope tube. So what you see here is that we had to invent very lightweight structures to hold the telescope stable and to allow us to get it into orbit. So we had a challenge in material science to develop these things. The bottom picture that I don't expect you to read, it's kind of a confusogram of heat flows. Because we're an infrared optimized telescope, we had to control our thermal flows very precisely. You can see on the bottom, solar input, the number of watts we're getting from the sun, and at the top, that had to be reduced to less than 1 watt. So we had to manage how heat flows through this infrared system very carefully. And we had to know where heat was moving at the milliwatt level. So that's the resting energy, the resting body energy of a flea. We had to keep track of that. And then the last part on the right, we had to develop a lot of very complex optical test facilities to make sure that this thing we built, knowing all those challenges on the left-hand side of the screen, could be realized on the right. Am I still coming through okay on the audio?
Absolutely. Thank you.
Okay, great. So those were the kind of macroscopic challenges we had, but we also had 10 things we had to invent before we could even do those macroscopic challenges. We had to invent the materials, sort of randomly walking around the screen here. In the upper right, it says backplane. We had to invent that material that was ultra stable at cryogenic temperatures and super lightweight. The cryo cooler, we had to invent a refrigerator that we could take up that would operate in space and cool one of our instruments to 6 Kelvin, 6 degrees above absolute zero. Micro shutters are little shutters that we developed. Those are about 10 microns on a side that we would use to open and close to selectively allow light from objects into our spectrograph so that we wouldn't be getting contamination from the rest of the sky. We had to develop super lightweight mirrors so that we could carry those into space. We had to develop application-specific integrated circuits, the ASICs, that could operate cryogenically because we had to keep the number of cables and wiring short because that introduces noise and heat in the system. And then finally, we had to develop coatings and sun shields to keep the whole telescope cool. So these 10 things had to be invented before we could even get to the macroscopic challenges. So the telescope design is a 3-mirror anastigmat. We have that primary mirror. The substrate is beryllium. It's hogged out to about a 2-millimeter face sheet of beryllium, upon which we deposited a coating of gold, roughly 1,000 atoms thick. And we use gold because it is the most reflective to infrared light. So I like to tell people that we built all this structure just so we could carry 1,000 atoms thick coating of gold to collect our light in space. After hitting our primary, we bounce off a secondary down into an elliptical tertiary mirror, which then reflects onto a fine steering mirror that we can adjust both rapidly and for small pointing changes so we don't have to do a lot of slews. And of course, one of the challenges we faced in developing this mirror was that when you're doing the polishing, that's done at room temperature. You don't polish anything cryogenically. So we had to measure the mirror cryogenically, then record where it was out of figure, warm it up, rub it down in those areas, cool it down. And the reason that we chose beryllium is that it is very repeatable in that cooling and warming cycle. Unlike most glass materials and blends of glass, they're not quite as repeatable, so that we knew when we would warm it up, polish it, cool it down, it would go back to its same shape. And then once you're at those cryogenic temperatures, beryllium is very stable coefficient of thermal expansion. And so it's not super sensitive to whether you're at 40 Kelvin or 50 Kelvin, it keeps the same shape. We carry 4 science instruments on Webb. The main camera for us was provided by the University of Arizona. Dr. Marcia Ricci was the principal investigator, and she paired with the Lockheed Martin, the Advanced Technology Center, which is in Palo Alto, California. And it is a redundant instrument in that there are 2 identical cameras that were built because we also use the NearCam to do wavefront control. Because we have an adjustable mirror, we use the NearCam to focus the telescope for all the other instruments as well. And so we wanted to have a doubly redundant instrument. In case one side would fail, we would have the other side to use for the other instruments. And so here are just some of the particulars for those instruments. Our spectrograph was built by the European Space Agency. It is a multi-object spectrograph, uses those microshutters, which were, the microshutters themselves were developed at the Goddard Space Flight Center in Greenbelt, Maryland. I'm going to skip to the bottom. The fine guidance sensor and near-infrared imager and slitless spectrograph, or spectrometer, was supplied by the Canadian Space Agency. It's dual-hatted in the sense that the fine guidance sensor is what allows us to lock on a target and remain pointed stably, and then the near-infrared, or NIRISS, is another science instrument. All those 3 instruments are our near-infrared instruments, operating from 0.6 to about 5 microns, and they use a specific detector technology. The mid-infrared instrument, or MIRI, was built by the European Space Agency and a consortium of institutions, and also had contributions from JPL and other pieces of NASA. So this is really a kind of a 50-50 instrument. And it operates at our longest wavelengths from 5 microns to 27 microns. So I talked about those super stable cryogenic structures. Here you see the back plane that's behind the primary mirror. And this is a carbon fiber graphic composite. You lay up these sheets with epoxy, and you have to know the behavior of this to roughly 38 nanometers, or 1/10,000th of a human hair. You have to know how its shape is going to change from when you launch it warm on Earth to when it gets to space. That sun shield, which is an iconic structure for JWST, is comprised of 5 layers of Kapton. And Kapton is just plastic. It's, imagine like a plastic baggie, a lunch bag, but this one's the size of a tennis court. It's aluminized, and those layers must protect us from infrared radiation from the sun, the earth, and the moon, which are all kept to one side. There'll be a slide about that later. The telescope itself is operated at the Space Telescope Science Institute in Baltimore, Maryland. And here you see a picture of the control room. It's a beautiful state-of-the-art control room. It's a little hard to see here, but out those back windows, it looks into a beautiful park there. And of course, they can lower those to make the room sort of light tight as well. But this is when they're getting ready to command the telescope from Baltimore. And Baltimore also runs the science program for JWST, just as it does for the Hubble Space Telescope. So this is a little digression I have in here. For a telescope like Webb, you require the support of the US government for a long time. And so I put on this chart many of the important events. Again, the font is small. I appreciate you probably can't read them, but there are various astronomical reports that come out over this time and mission phases. But you can see we've gone through 5 presidencies till we had this launch, from when it was conceived to launch. So maintaining public support is enormously challenging for programs like this. And I want to say that groups like yourselves, other people interested in science, play a huge role in letting folks know in our government how important science is to everyone. And it's not only astronomy, although we all love astronomy here, just maintaining that support for science is critical, because these are almost generational efforts for some of these big things. So I'm going to try to run some movies here. This first one is going to show where we operate the Webb telescope. And so if the animation gods are with me, let's run this here. So because Webb is infrared optimized, we want to keep it far from Earth, which is different than Hubble. Hubble's very close to Earth, which is close to a source of heat. So we want to get far away. So we're 4 times farther than the moon. And we execute what's called a halo orbit. We don't just sit behind the moon. We're in this big, long orbit that lets us always see the Earth. So we can always communicate to Earth, receive commands, and send data back. We're not kind of hiding behind the moon. Now, we can't look at the sun and we can't look away from the sun, but you can imagine us always looking perpendicular to the sunlight. And so that means one side of Webb is hot and the other side is cold. Now, Hubble is different. It's much closer to Earth, so it has that tube to protect it from the scattered light from Earth. So as Webb is out there orbiting, when it looks at the sky at any one time, it can observe in an annulus, and we can tip back and forwards a little bit, and we can also rotate for just a few degrees. We don't want the sunlight to see any of the instruments. And so at any given time, we see an annulus, and then during the course of a year, we're actually able to see the whole sky. And if you then take those 4 instruments we talk about and project them on the sky, that's what the field of view is like. We'll see a little bit more about that later. And I'm going to skip over this little ad at the end here and go to the next video. So after many years, 2 decades of development, we took one of the contributions from the European Space Agency, which was a launch on their Ariane 5 rocket. And this shows a little bit about that. This is the elevator that you ride up alongside the Ariane 5. You're closest to the solid booster. You can see the liquid oxygen tank bulging out a little bit in the center there. This is now December of 2021. Here we're at the top, and there you can see Webb mounted atop the Ariane 5. This shows the process to put it on there. This was incredibly nerve-wracking to watch them lower an almost $9 billion spacecraft through a hole with just a few inches of clearing. Then they encapsulated it and rolled it out on a beautiful sunny morning, but you're in the rainforest, so that beautiful sunny morning turns into a giant rainstorm. And then on Christmas morning, now here we see a view from the Ariane rocket of Webb after it has left. And we saw this sun shield, or the solar array, excuse me, come out within, I would say, like the first 90 seconds that came out. And I'll tell you why that was, I mean, that was a really emotional moment. And when I show you the next video, so that solar array coming out when it did is also shown in this next little video, which shows us all the deployment sequences that the telescope had to go through once it launched. And now we don't have camera footage of this. This is just a computer drawing. So if you see at the top, there's an elapsed time. And at the bottom is a distance. And so you see it says 30 minutes, the solar array coming out, and it came out in less than 2 minutes. And that's because the orbital insertion that the Ariane 5 gave us was so perfect that the computer sequence that was going to check to make sure we were in the right 6-dimensional space of position and velocity that we would correct with our own fuel was essentially spot on. We had to use no fuel, and so the solar panel kicked out immediately. And that's when we told us we essentially had a perfect launch that was going to double the lifetime of the telescope on orbit. You can see now we're after a couple of days, we're past the moon. We begin deploying those sun shields, and those sun shields had covers that protected them during the launch. We'll see in a little bit that those covers will roll back. About the only nail-biting moment for me during this deployment sequence was when We did not get a signal from one of the switches that indicated that the cover had deployed successfully. We'll see those covers roll back in a second. See how they peel back, and then they connected with reed switches that basically said, I'm deployed. One of those reed switches did not indicate deployed, and we had a thermal engineer, though, say that he could see one of his temperature sensors was starting to drop, which would only happen if the cover had rolled back, and now a little bit of that cover was blocking the sunlight, allowing that temperature sensor to start cooling down. And so even though the reed switch didn't register it deployed, we could see another way that it had deployed. The sun shield layers have to be separated. There are 5 of them, and the Y5, that number comes from an engineering study that optimizes the amount of heat rejection and micrometeoroid penetrations versus mass. 6 would be better at thermal control, but not that much better, and it adds that much more mass and complexity. So 5 is the optimal number. Once the sun shield was deployed, we turned on that cryocooler so that that MIRI instrument, the mid-infrared instrument, could get down to the 6 Kelvin it needed to detect radiation. Once the secondary deployed, we actually now had a telescope. Light could hit the primary and make it into the instruments. Of course, we wanted the full telescope, and so that doesn't happen until the wings deploy to give us the full 6.5 meter diameter mirror. And so it's about a 2-week deployment sequence. But we didn't actually reach our orbit out at L2 until about a month, and then actual commissioning of the telescope took another 5 months before we were ready to begin science operations. And it was during this period of commissioning where we first started to get a glimpse of how well the telescope was performing. And that came when we had a focused image for all of the science instruments, and it was seen here. Again, we learned this in the spring of 2021, and I can tell you there were a whole lot of incredibly elated people when they saw just how good the telescope was performing. In fact, pretty much exceeds every measurement capability that we had planned for it. And I'm sure many of you had seen, this was one of the first images that came out from the telescope. It's in the Carina Nebula. It's a star-forming region. This was the first picture I saw from the telescope that I have been working on since 1996. And I was almost speechless. I think the first thing I started doing was giggling. It was just so beautiful. I couldn't believe the telescope worked as well as it did. So I want to transition quickly now to some recent science results from the telescope, now that it's been doing so well for so many years. This is an image of another star-forming region, and I'll draw your attention to the upper left, where you'll see a number of jets of star formation, all more or less co-aligned. And this is telling us that the accretion disks that surround those stars and help to entrain the jets of material all have more or less the same axis, which tells us about the gas cloud that they all are forming from. and can tell us about the magnetic fields that thread through those gas clouds. Um, the sharpness of Webb images in the infrared is taking us to new places in discovering a lot about star formation within our own galaxy. When JWST was conceived, I like to tell people there were 2 exoplanets in the universe. Of course, they were all out there. We just didn't know about them. Webb was designed to study that very distant universe, but people are using Webb to study exoplanets now, almost in equal measures with the distant universe. And here you see 2 spectra of a tidally locked planet, WASP 39b. You're seeing both water and carbon dioxide lines. But the evening and the morning terminators, if you will, have different temperatures. So even though this planet is tidally locked and isn't rotating, there is a temperature difference across the planet. So we are using Webb to learn much more about how exoplanet atmospheres behave. And much as the 20th century can be thought of as astronomers building ever bigger telescopes to chase galaxies across cosmic time, I think the 21st century will be astronomers building ever more capable telescopes to learn about exoplanets, because it's clear we have much to learn. This is a fun picture that just came out recently showing the effects of gravitational lensing on a pair of galaxies, spiral and a more edge-on system. And you can see that spiral and the dusty edge-on system in several reflections or several images through this gravitational lens. And of course, the one right in the center looks like a question mark. The dot at the bottom of the question mark is actually a different galaxy altogether, but it exhibits one of the things that astronomers are doing with Webb. They're combining nature's telescope, gravitational lenses, and clusters of galaxies to see even more distant objects than they would be able to otherwise. One of the things that Webb is teaching us is about how the very first galaxies were formed in the universe. You might have heard when some of the first results came out, people were saying, oh, this is showing the universe was building, it was breaking how we thought galaxies formed. Subsequent discoveries have found what we're actually seeing is probably much more active black hole activity early on. And so it's not breaking how galaxies were formed, it's saying that black holes played a more important part in the early universe. But we built Webb to see the most distant galaxies, to find some of the first galaxies being formed. And what you see here is a spectrum showing a galaxy at a redshift of 14.3. So this is a galaxy that formed 290 million years after the Big Bang. It's finding those distant galaxies. We knew it would, and this is only a year 2 observation, so we're just learning now how to use this facility. I expect much more from this in the future. And so I just have a few text slides here to sum up things of what I think to date are some of the highlights for Webb. I'm not going to read through all these things. You can read them faster than I can talk to them, but it is in fact fulfilling the promise of those early universe studies, and it's teaching us very interesting things now that we can study galaxies evolving essentially through their complete history, from nearby to the most distant, about how that process works. Because it's got this infrared vision that can peer into dust clouds, we're learning more about stellar life cycles that we were unable to before, and it's just beginning to scratch the surface on some of these exoplanet investigations where we're seeing compounds never seen before in the atmospheres of exoplanets. And we're starting to look at some of those systems that we really want to hope to someday find a rocky exoplanet with an atmosphere that might be a habitable type atmosphere. We haven't found one yet, but we are still looking. And of course, it's made many observations within our own solar system too, where we can look at anything exterior to the Earth orbit. We can't look back at the sun because of that architecture we have for the telescope. All the data that come from Webb are public. They go into the Mikulski Archive for Space Telescopes, or MAST. If you just Google MAST or Space Telescopes, you can get to this page. And if you don't have an account, you can sign up and create one, and you can download all the data that come from not only Webb, but Hubble, TESS, and many other missions have their data archived there. There's a little obligatory spin-off slide we have on this. I don't think you would ever do these things just for the spin-off. If you wanted to invent these, you would do them more directly. But Webb has actually, in its process of developing, made several technologies that others are using. Probably the most commercial is the technology we developed to measure those mirrors has now found its way into many opticians' office. And if any of you have LASIK, you may have used technology, that same technology that Webb used to measure its mirrors. I'll leave you with this slide here. If you want to find out what we're doing at any moment, you can go to nasa.gov/web, or you can follow us on any of the social media. And I see I need to replace that Twitter icon with an X icon. I keep forgetting to do that, but that is another way to follow what we're doing. And then with that, I will close, and I will be happy to take any questions you might have. And thank you very much for inviting me and letting me tell you about the James Webb Space Telescope.
Okay, well, how many questions am I allowed to ask?
How many you got?
I mean, I've got two questions. Okay, the first one was, so it's pink for protection and gold for reflection. Is that the colors on the James Webb telescope?
The gold comes from, it actually is gold on those primary mirrors, and gold is the best element for reflecting infrared light. It's something between 98 and 99% reflective. So while you may think, wow, isn't that extravagant to put all that gold on there? Because it's so thin, it's the same mass of gold as in a golf ball. So, a few hundred grams of gold. And then what was your second question?
So I wanted to ask, how do I go from barely starting out college, I'm going into physics and astronomy myself, and how do I go from here to where you are at right now? Like, you got any advice for me?
Well, so one of the things I would encourage you to look into, if you're interested in space science, would be an internship with NASA. And so there is a website, intern.nasa.gov. There are internships at all NASA centers. And so Johnson Space Center is closest to you all, but we have interns at any of the 10 NASA centers. And if you're interested just in astronomy in general, well, there are many places to do astronomy across the country. I actually started out as a ground-based astronomer myself. Most of my early research involved work at the Kitt Peak telescopes in Arizona, Cerro Tololo telescopes in Chile, and the telescopes on Mauna Kea in Hawaii. But after doing that, I ended up going to the Goddard Space Flight Center to work on Hubble data right when it was launched. And then I sort of wandered into space science. So if you're interested in ground-based or radio or optical, there are many places to go. But if you really want to do NASA, I would encourage you to look into an internship where you can apply, and you can look and see there are many, many projects. People say, I want an intern to help me work on something like this. That would be best advice.
I saw the anticipated lifespan of the telescope was going to be like 5 to 10 years, 15 years, or something like that. Why is it going to be anticipating such a short lifespan for it?
Sure, there are a few numbers in there to keep in mind. The first one is what we call the prime mission lifetime, which is almost always 5 years for astronomical missions. And that just has to do with how you buy parts from the aerospace industry. And when you say you want a 5-year mission, they will guarantee that my parts will work for 5 years and at a certain cost. Now, if you wanted a 10-year guarantee, that would dramatically increase the cost. And of course, what we found for many space missions, if they work initially, they tend to work much longer than this prime mission lifetime. So almost all things are initially spec'd for 5 years. So Webb has a 5-year prime mission. We knew that we wanted to use it for more than 5 years, and it would probably last for more than 5 years. So we sized the fuel tanks for 10 years of operations. We use fuel on Webb to what we call desaturate the reaction wheels. Most spacecraft don't move with using thrusters. They have reaction wheels that spin, and through the principle of conservation of angular momentum, can turn the spacecraft by changing the rate at which these wheels spin, and the spacecraft turns in the opposite direction. But eventually, you might spin these wheels up such that you can't spin them anymore, and now you need something to de-spin them. You must push against something to spin them, and that's what you use the fuel for. So we sized the fuel tanks for 10 years of likely operations for the mission. We also knew that we had to have some fuel to possibly correct our orbit once we were launched. And so we factored that in as to how much fuel we would need. Because that launch was so perfect and we didn't have to use any of that fuel, that meant we had the fuel that we budgeted for those early corrections, we could now use it for desaturating the wheels. And so that meant that initial 10 years of operations now is going to be between 20 and 25 years of operations just based on fuel. It's always possible that some component will fail before that, and many spacecraft degrade naturally over time, but we won't run out of gas, so to speak, until about 25 years.
Let's pray. Isn't there?
Oh, I see the.
Oh, you got something?
Yeah, go ahead.
Oh, isn't there a certain amount of fuel that's needed to do corrections with the orbit around the Lagrange point?
That fuel comes when we, need to do occasional corrections to that orbit, but they're very well known, very well understood, unless you had some big disturbances to the spacecraft position. And when you take those into account and the desaturation, you still come out with that number, 20 to 25 years.
Gotcha. Okay, understood.
And I see there's a question in the chat about one of the panels damaged by a micrometeorite. Yes, in fact, that happened in May of 2021. There was a micrometeoroid hit on one of those mirror segments. Turns out not only is Webb a very sensitive telescope for infrared photons, it's a very sensitive telescope for micrometeoroids. So they're learning about that as well. But that was part of our error budget we knew that there was going to be a certain amount of micrometeoroid damage over the life of the telescope. And so the figure for how sharp the focus needs to be was spec'd such that at the end of that lifetime, 5 or more years, it would still be an excellent, sharp image producing telescope. So when we got that big hit very early on, it was a little concerning because we said, geez, you know, the models we've been using told us that was a pretty rare hit. And it turns out we haven't had a hit of that size since then, the energy in that. So the statistical models were right. We just had our bad day early on. And now we correct the mirrors time to time. Each of those mirror segments, there are 18 of them, are adjustable not only in pistons, so we can move them in and out. We can tip and tilt them, and we can adjust their radius of curvature. So as micrometeoroid damage happens over time, we adjust the mirror to keep the focus optimal. Oh, and then the question was, does NASA have any plans to service the telescope in the future? We have no plans to do that. This was one of the very first studies we did in 1997. We looked at the ability to service Webb. So if you take yourself back to 1997, how did NASA get to space to service things? Well, they used the space shuttle. That was all we had. We knew that Webb was going to be put 1 million miles from Earth. No astronaut has ever been 1 million miles from Earth. So we knew that humans servicing was not possible when we started the mission. Because we're this infrared optimized mission too, we didn't build the instruments, the science instruments, in the same way as Hubble, which are very modular. You can almost imagine they're just these self-contained boxes of electronics and optics that you can put in and take out very easily. We separated the electronics from the optics of our instruments. And so if you needed to replace any of those parts, it's not as simple as taking something out. You have disparate system or dispersed systems in the telescope. And so simple repair, even if you were to do it with a robot, would be very complex. So I think by the time Webb would needed to be serviced, astronomers will have already decided there are new problems to tackle, and they want a different telescope by then anyways.
Any other questions? Can you give us an approximate idea about how much longer the Hubble Space Telescope can be useful?
Sure. Hubble is now in its 33rd year of operation, and it is now operating in what we call one gyro mode. So they're using only one gyroscope to control it because the other gyroscopes have failed. There were 6. 4 of them have failed. We have 1 that we're operating on and 1 as a backup. So Hubble is probably nearing the end of its science lifetime the way we understand it now, where people can use it for sort of whatever they want to look at. That doesn't mean that if we had a gyro failure, we wouldn't think of some other way to use it. Ultimately, because Hubble is in this near-Earth orbit, it will catch enough drag from the atmosphere and it would tumble back down. Now, we actually can't let that happen because there are pieces of the telescope that would likely survive the re-entry, and we can't let that hit anyone. So there's always been this plan to either someday attach a deorbit module that would allow us to have a controlled re-entry of the telescope. So you would direct it into the Pacific Ocean, or you would use that same module to boost it up to an orbit that wouldn't decay for 1,000 years or something like that. And then our future descendants could go up in spacecraft and look at the Hubble Museum that was orbiting the Earth. But that's something that won't happen for Hubble till about the mid 2030s is when we would have to make that decision. So we're thinking about it now, but it isn't urgent today to do something.
Any other questions? All right, thank you so much. It's a treat just to have you speak with us and take your time to tell us about the telescope and the mission, and really, really, really appreciate it. Thank you so much.
You're welcome, and thank you for inviting me. Enjoyed it. Great questions.
Well, you're welcome to hang around if you want to, but we've
Yeah,
got
I may listen to a little bit of business here. I'll turn my camera off though.
there's some space stuff left. So, all right, thank you, sir.
Yeah.
So we're gonna have a 10-minute break. So watch your eyeballs. right. All right. First tickets. All right. Ticket number 4807188. Not me. Not it. 4807188. All right. So next one. 48. Oh, there you go. Oh, well, here. 4807231. Not it. Yeah. I don't know. That's up to you, pal. Oh, I've got something for you right here, buddy. This is for you, no? It's got your name on it, man. All right. Next one. What do we do? 5? All right. 4807183. Not it. 4807183. Huh? No? It's definitely not me. Oh, okay. Well, give me about 50. All right, well, we're going to try another one then. Okay. 4807138. 4807138. We have a winner. One more? Let's do one more. Huh? Sure, hey, we're here. We got the microphone. I'm all warmed up. Okay. Still not it. 4807109. All right. Very cool. Well, you can have these tickets back. They're useless to me. They were useless. I don't know. Okay, all right. All right, so it's time for What's in the Sky. With me, still. Where's my laser? All right. Chris, whenever you're ready. So this is for what's going on in the sky for the next month before the next meeting. Our Corey Morris, which is a new member of the club. Next slide, featuring his picture of the Pleiades. Nice close-up, dusty shot of the Pleiades. So next slide. Okay, so bright comets this month. So 13P Olbers is continuing to slowly sink in the sky. It's fading as well. Hope you got a chance to see it. You've got a little bit more time to see it, or you're going to have to wait another 72 years or so. Good luck with that. And then we've got the star of the show that we're anticipating getting possibly as bright as magnitude 2, which is just a little bit dimmer than Polaris. I think that's right. Do I have that right? Anyway, it's going to be bright. It would be a naked eye comet. Right now it's, well, it's saying that in like a couple of weeks. I always kind of make these measurements. The data here. Where's my button? Ooh. Laser. This right here, these figures right here, and where it is in the sky is based on halfway between now and the next meeting. So, and by the way, just so you know, this stuff's getting recorded. I will actually every month when I do this thing, I print it to PDF, and when I remember, it goes immediately onto the group's IO site. Next slide. Occultations and close approaches. Well, there's one, it's notable. There's actually one that happened this morning that Patrick actually reminded me about, which was Saturn and the moon. But the moon is going to be very, very close to the Pleiades on Sunday, September 22nd, right before sunrise. And, well, Patrick's the one that reminded me of. This is actually his picture of the Moon-Jupiter conjunction that happened just a little while back. Yes, sir. That it occults Neptune? If you know, if it occults Neptune, unless I missed it, I mean, like, unless I didn't see it because I like go through all those things on the calendar and stuff, that it's not visible to us, or it's in the middle of the daytime. It's 2:30 in the morning. Ooh. Okay, all right. So that's worth, yeah, that's worth checking out. If that's tonight. Okay, yeah. So. Right on. Okay, thank you. Yeah. So there you go. Next slide. And then there's the nova of the century. So if you're looking for a before and after set, you're probably going to want to get in that before picture. Everything that I see is like, oh, it could be by the end of September. It's really any day now. So definitely a cool thing to be looking for. And that's right here, and it's still up in the sky at night. It's sinking into the west as time goes on, but it's still up in the sky for us. Next slide. So this is the time of year for the zodiacal light. It happens near the equinoxes, and it's basically when we're at a particular view, with the ecliptic being as high in the sky as it gets during the year, during the equinoxes. And what the sun is doing, what we're seeing all the dust within the inner planets on the ecliptic plane being illuminated by the sunlight. And so at this time of year, it is something that you'd look for at a very dark site, like our dark site, on a moonless situation right before sunrise. And the cool thing is that it intersects up higher in the sky. It intersects the Milky Way. Next slide. All right, so the sun. So we've got AR 13825. You'll see it as 3825, and it shot out a Class X 4.5 flare as it was coming around the eastern limb here, and it's been moving. You know, as the sun rotates, it's been moving towards us. So we're something to keep an eye on as of. Yesterday, you've been seeing any of the things in the news about the fact that it's, created a strong G3 electromagnetic storm. We just got Tom's got it on his phone, but it's a text from Bruce Campbell. He took a picture from his airplane window on the way to Juneau, Alaska, with an amazing shot of the aurora. So catch up with Tom sometime after the meeting. It's just a beautiful shot, or we'll just post it. It's just from a plane. Beautiful. So anyway, This particular active region right here is definitely something worth, crossing your fingers about. We might get thrown back into the 1800s yet. Next slide. All right, so our next new moon is on Tuesday, September 3rd. That's not right. Oh, man. You know how many times I go through these slides to check this stuff? Anyway, yeah, right. So the last new moon was on Tuesday, September 3rd, ostensibly. We'll go ahead and do the math on that, and that would be 28 days later, if that's correct. Anyway, this is my picture of the annular eclipse last year. Next slide. Full moon. So the full moon's on Tuesday, September 17th, so I am correct. 14 days from now is the new moon, so there you go. You're welcome. Huh? It's been a long week, pal. It's been a long week, brother. Thank you. That I got. Okay, next slide. Let's see if we can limp along through the rest of this. Okay, so happening right now, in progress, is a partial lunar eclipse. It is not an impressive lunar eclipse. At the very best, which actually happens at 9:44 p.m. this evening, we're getting about 3.5% of the umbra on the edge of the moon. So it's going to be darkened by the Earth's penumbra, but just a little bit of a bite out of it. If you didn't know what you were looking at, you probably wouldn't even know what was going on. But it's happening right now. It looks like we got a sky to be able to see it, so it'll be pretty cool. My wife was like, well, why don't you just have the meeting outside? I was like, yeah, no. Next slide. Oh, that was Christian Sintik's. This was of the November 8th total lunar eclipse in partiality. So it's a good picture. Next slide. Neptune opposition. So on Friday, September 20th, Neptune will be at opposition, and it's going to be in the constellation Pisces, where that takes place. Magnitude 7.8. If you've seen it in a telescope, nice tiny little blue disk in a dark sky. You'll get, and it'll be a dark sky all night long. You'll get to see Triton if you got a good aperture. And this picture right here, this is not from Voyager. I will remind you again that I've had a very long week, and it's only Tuesday. So that's how bad it's been. This is actually a picture from the James Webb telescope. Took a picture of Neptune here with the rings. This is actually the best shot of the rings since Voyager 2. So, yeah, very cool. Next slide. And then the autumnal equinox. So that's on the 22nd of September, 2024. And now the nights are going to be getting longer, so hooray. Next slide. Right. No, they're equal. They're equal now. Nights will be getting longer than the day. Okay, all right. I knew I'd get it right eventually. All right, so we've got an annular solar eclipse. It is not visible to us, but if you happen to be on Easter Island, you get this weird, cosmic treat of being on Easter Island and seeing an annular eclipse. Time and date, I searched, I scoured the internet to try and find, okay, so what sites are doing this live and stuff. I don't know if NASA's doing it, but I do know that timeanddate.com did have that on their website, that they're actually going to be doing a live broadcast. So, hey, eclipse at Easter Island. This picture right here actually happens to be a picture of the total solar eclipse that went through Easter Island in 2010. Next slide. Then there's the Draconids meteor shower. So it's from 21P Gaikubini Zener, however you pronounce that. But it's the night of October 7th, and because it's, thank you. Is that my phone? No, it's not my phone. So I have the same alarm. So it's the night of October 7th, and the peak of the meteor shower is actually in the evening because of the placement of Draco up in the sky. And that's, of course, where the radiant is. It goes into the morning of October 8th. It is known for having outbursts, quite unpredictable. The last time that I sat and watched the Draconids in a really dark sight, it was as good as a pretty darn good Perseids, so you never know. Next slide. Yes, and then there's 363. You've heard about this? Have you heard about this? This is an asteroid that's coming close. You know, I decided to throw this in because magnitude 13 is, of course, you know, approachable to a telescope. It's 400 meters in diameter, so it's got some size to it. It's coming as close as 2.2 million miles. Often when we get asteroids that come close and they've got enough reflectance to them to be bright, that you can actually literally watch them move in the sky. It's really cool. I saw that with an asteroid that went through, I think it was Florence, that went through Delphinus a few years ago. But thought I'd point this one out. That's Saturday, October 12th, when that happens. Next slide. Gosh, I didn't even say what constellation it was in, did I? So, Google it. All right, so the constellation that I'm featuring tonight is Cepheus, the king of Ethiopia. And who is his wife? Huh? Who's his wife? Cassiopeia. And who's his daughter? Yeah, and who's the guy who saved her? From what? Nope, Cetus. We almost had it. Anyway, there's a lot of drama going on in this part of the sky from a mythological standpoint. It's known for variable prototypes, so those that study variables and stuff, that the nature of the variables on which they are based, there are a few of those stars on which they are based that are in Cepheus. Lots of really big stars, and we'll get to that slide in a second, but lots of really, really big stars, like bigger than the orbit of Jupiter sort of stars. This constellation never sets, and it's got one star with known planets, and it was first cataloged by Ptolemy in the 2nd century in his Almagest. Next slide. So Herschel's Garnet star, beautiful garnet color. It's a large star. It's one of the most luminous stars in the galaxy, Milky Way that is, and it's got a radius of 7.7 astronomical units, and that is, of course, a surface of the star beyond the orbit of Jupiter. So it's a pretty big star. It's going to go supernova in a few years. Next slide. And it's right here, down at the bottom of Cepheus. Next slide. Other enormous stars. So we've got VV Cephi A and V354 Cephi and RW Cephi. And you can see that they're bigger and bigger and bigger. These are all within the orbit of Saturn, but they get increasingly large. There are only 2 stars that we know of that are larger than these stars. And they're down here in the southern region right here. By the way, that's the Garnet star right there. So those are the big stars down there. Next slide. So there's the Wizard Nebula. So this was discovered by Carolyn Herschel, and it's got a young open star cluster inside of it. There's actually a couple objects in Cepheus that have this sort of characteristic, and it's kind of hard to see with the eye in a telescope unless you've got an oxygen 3 filter in a really dark sky. But it's possible, but it's beautiful photographically. Next slide. And this is George Lutch's beautiful shot in Hubble palette. Next slide. So NGC 7538. So this is a combination emission reflection. So it reflects light with dust that's in the area and emission from ionization. This nebula it's right here. It's got the largest known protostar, and it's basically a mass that's within the hydrogen cloud there that's 300 times the size of our solar system. So it's a large mass that will compact, of course, but it's definitely a thing. Next slide, and this is David Koch's picture of this. You see it's a little bit fuzzy. It's because this is a very little bitty thing that's actually, if you looked over here, that would be the Bubble Nebula up there to the northwest of it. And there's the Bubble Nebulas there. I think the cave is over here. And this little guy right here is kind of in between. So I had to really dial into his picture. Sorry, Dave, to pixel peep, but I had to get a picture of it. Next slide. In GC 188, this is also Caldwell Catalog's first entry. This is an open cluster that's interesting because they usually drift apart. You know, over time, they drift apart. It's usually caused by galactic gravitational forces that actually drive a open star cluster to start to spread out. And because this star cluster is actually so far above the galactic plane, the galactic tidal forces just don't affect it. So this thing's really old. What is it? 6.8 billion years old, and it's just they've stayed together. So that next slide. This is a picture from somebody we don't know, but there's the star cluster right there. So next slide. The Iris Nebula. So this is a reflection nebula that's got another open star cluster embedded inside of it. It's beautiful, bluish color. Next slide. Right here in the bottom here. And this is Bob Circus's fine picture right here. And you can see that it's surrounded by a bunch of dark nebulae here. It glows a bluish color is the nature of the diffusion that happens when the starlight is diffused by the dust in the area. Next slide. Okay, so IC 1396. It's like, what's IC 1396? Well, inside of IC 1396, which is this big blob of stuff down here, is the elephant's trunk. It's all illuminated by a very massive, very luminous star. Next slide. And this is a beautiful picture by Trevor, our very own Trevor Bray, in Hubble palette once again. And this accumulation of stuff, obviously you can see the elephant's trunk there, the elephant head situation there, but it's thought of to be a birthplace for stars, kind of like the Pillars of Creation. It's just this, accumulation of gas and dust with protostars inside. Next slide. More about constellation Cepheus in all the usual suspects here. Also, about 125 pages in Volume 5 of the Annals of the Deep Sky, which was co-authored by our very own Dennis Webb. Next slide. And we've got Stephen Kennedy with the Lobster Bubble and Cave Nebula. So that little, I don't know where it is. It's somewhere. I think it's that guy right there. Is the little nebula that I was talking about earlier. But this is Stephen Kennedy's, and keep looking up. Thank you. And watch your eyes. Solar glasses on. I don't even know if I should keep it off. We've got slides. So, next slide. Monthly reports, announcements. Well, let's start with Bob Circus.
Good evening, everybody. There's going to be a work. I'm heading out to Rising Star on Sunday afternoon. I'm going to work on the Noble Observatory and the binoscope. So if you want to help out, that's great. My goal for the Noble is to put the mount on the pier and get the mount itself working. That's the goal for that part of the project. And then I want to start the refurbishment of the new binoscope that was donated to us. So that's cleaning the exterior. I want to measure. I need to take some measurements so I can have some caps built for it. And I want to drag it out and put some eyepieces in and see how it works. So that's what's going on Sunday. Thanks very much.
Cool. Does everybody know what a binoscope is? It's like a giant, it's a pair of binoculars, except each side is a telescope, and it's what, 12 inches? Two 12-inch telescopes?
Wrong, 14 and a half
14
inches.
and a half. So we're talking about enormous binoculars, not a handheld device. So that got donated to us, and yeah, right on. Next slide here. I think we've got an announcements thing. Ah, yes. So Michelle, you've got things to say about the ranch formerly known as 3RF. Oh.
Thank you.
You told me to do this.
Yeah, good job. Just spot checking you, bro.
Hopefully you have seen the email. There has been a lot of up in the air stuff since this past summer with the Three Rivers location, because it has been acquired by Texas Tech University. And so everything was sort of put on hold. And it's like within the last week and a half, maybe, we have discovered, yes, they're going to continue to book events out there. So we have secured the weekend of October the 25th through the 27th. So it should be a great weekend for viewing. For those of you, and we have so many new members and some who have never been out to Three Rivers before. As you referred to, it used to be run by the Three Rivers Foundation. It is now referred to as Three Rivers Ranch, which is a mouthful, so I usually just call it Three Rivers. But it is a great weekend. The club pays for a bunkhouse for the men and a bunkhouse for the women. So the club pays for that. So if you just want to bring out your sleeping bag and put it on a mattress and sleep in the bunkhouse, then that's great. All you need to worry about is bringing your food. Other accommodations, there are some RV sites that will be put into a drawing if we have more than the number of sites available. We have 6 cabins available, and those also will have a drawing done. The drawings for these are going to be October the 1st. It will be done via Zoom. So everybody can see how it is, and if you want to tune in, you can see if you've got a winner on the lottery or not. So if you have any other questions, see me after the meeting. Anyway, and I know we've already got, what have I got? What I've tallied so far, including everything I've gotten through this evening, we've got, I think, 21 people coming, in between husbands and wives. And so it's going to be a great group if that's the beginning. Even when it's been raining out there, we have had a fun time simply because it's a good time to visit with other club members and see what's going on. We have access to a couple of larger scopes that are at that location. They are manned by volunteers. So no, you don't get to put your hands on the 30-inch unless you've been trained in it, but the volunteers will run that for us. And I think last year it was, one of the volunteers was running it through all the different parts of the witch's broom. Is that what it was? So it's really cool to look through there. If you want to attend, answer that email or just one-off email me. I'll get you on the list. Let me know how many people are coming. If it's just you yourself, you and your wife, you and your family. If you want to be put into the cabin lottery, I'll need to know that. The cabins the club does not pay for. The cabins will be $250 for the weekend. So that will be paid for by you if you want to go in for a cabin. Just be aware of that. Same with the RV sites. We've got water and electric at $25 per night, and then the electric-only sites are $15 per night. Again, you are responsible for your own food throughout the weekend, except for Saturday evening. Our regular catering company is going to be available, so she will be doing our catering Saturday evening. The meal will be $20 per person. If you want to sign up for that, I need your name and I need $20. So the sooner you can get that to me, the better. For other foods, we've discovered there's a Walmart that's right there off the freeway as you go down to 3RF, so you can stop in and get milk or other foods you want to keep for the weekend in your cooler, or if you're lucky enough to be in a cabin, in your refrigerator. And then we've also got a pizza place that's in Crowell that's really good. There's a couple of fast food places up there in Vernon near the freeway if you want to pick up something there. So there, you can pretty much take care of yourself there. Let's see. What kinds of questions do some of you have, especially you newer members, that I may not have covered in the email? Really? I was going, how do I make this sound, how do I make people understand it who've never been there? And I knew we had a lot of new members, so I tried to explain as much as I could. Again, if you have any questions, email me, see me after the meeting, and just let me know. Okay? Thanks.
All right. Any other announcements? Good? Okay, next slide. All right, monthly reports, Mr. Monahan. McMahon. Oh, thanks, Bob. Hang it up.
All right, thank you much. Next slide. All right, I got a couple this weekend. We got one up in Rome for community. It's Friday nights from 8 to actually 10 o'clock. Then Saturday we'll be helping out the Boy Scouts with their thing in Mansfield. So you can show up at 6 or you can show up around sundown. Next slide. So the 28th, a week from this Saturday, will be our next attempt at the Dinosaur Valley Star Party. Hopefully the weather will hold up, unlike last month. So it's really one of our darker skies for star parties. We get a good turnout, so hope to see you there. And this bottom one, talked with Robert Circus. This is going to get postponed to a later date. He just needs to plan some more, but we would like to do a star party for the school district in there. It'd just be at a different time. And let's see, I think got one more, a couple more. And then on the 5th, we have one in South Arlington. And then on Tuesday, we've done this one before. They have a little gathering out there, so we'll do a star party for in Grand Prairie. Again, if you're able to help, let me know. I'll post these on the e-group. Thank you.
All right, next slide. Next slide.
Okay, our Tandy Hill Star Party. One word describes the September 7th Star Party. Fantastic. The weather was the best we've had all year. I brought out droves of people. We had somewhere between 50 and 60 people. There were, I would say, 4 or 5 telescopes set up on the perimeter of where we were by non-members. In fact, one of the non-members was there. I was talking to just a few minutes ago in the parking lot, who had been to this meeting. He's not a member, but he's going to join, and he's planning on coming back again and setting up on the perimeter. Next Tandy Hill Star Party is on October the 12th. Sun sets around 7 p.m. So hope to see you all out there. Anybody that's new in the club that wants a telescope, wants to know about a telescope, come on out, because we have all types, all 3 major types. And if you need information on setting up a scope, just come on out, and we'll be glad to help you. Oh, one other thing, on a semi-personal note, the powers be that have requested that I come up with an alternate for the Tandy Hills, for being a coordinator for the Tandy Hills. This is just in case I get hit by a beer truck or something on the way out to a Tandy Hills Star Party. So if anybody would be interested in doing that, just send a message out on the e-group, and we'll sign you up.
All right, next slide. All right, so next Tuesday, 4th Tuesday every month, we have young astronomers. Class is going to be on Saturn. It's in opposition, or was just in opposition last week. Saturn rises about 6:44, it'll be about 21 degrees in the sky, so we'll be able to see it very well at 8:30. Sun sets at 7:30. Class starts at 7. Robert and I will be there with telescopes, so we can always use a couple more telescopes. And then need some more volunteers to help prepare classes. Could use some other people rather than me just giving classes all the time. You got a question? I can't hear you.
How did you volunteer for that?
I'm sorry? All right. And it's at the Bedford YMCA. We always use more people to help prepare classes. Next month's class is going to be on Uranus, Venus opposition, real closely. So we're going to show them both this weekend, but we'll have the class on it next month. And in November, we're going to have a class on meteor showers in preparation for the Geminid meteor showers on 13, 14 December. Questions? Next.
Good evening. So we have, next slide, please. So we have, we did a star party out there last 2 weeks ago. It was very well received. We had, I can't remember, I think we had seven members out there helping with the spouses of veterans. A couple of weeks ago, it was really nice. It was well received, and I think everybody had a great time. We have 2 more this month, one tomorrow, and that's a Texas Tech photography retreat. We're using that to build an astrophotography class. So we have a pretty good slide deck going on that. And then the next one will be Friday the 28th. Higher Ground Photography Retreat. This is a retreat for veterans.
Friday's the 27th.
I'm sorry, why does it say Friday? That should be Saturday the 28th. Saturday the 28th. And it's, for the Higher Ground Photography Retreat, it's a group of veterans. These 2 groups are small. There's only 14 folks. And so we pretty much got everything lined up for that. We're going to have 2 more in October. Boy, oh boy, I'm getting all messed up on calendar. We'll have 2 more in October, and that'll be it for this year, and the foundation's going to ask us to come back and do this again next year. So with these 5, that'll make 10 or 11 that we've done this year. So they're great events. So hopefully, if you have an interest for October, there'll be more emails coming out, and you can join us. One of them in October is actually your quote repeat customer. They asked us to come out again, and there'll be 60 folks out there, so we'll need a lot of help. Thanks. Oh, yeah, this is the location. Hey, Patrick, there you go. Take a picture. So basically the way it works is when you drive out there, there are 3 gates. The gate we go in is number 2. If it doesn't say gate 2, you gotta, if you're gate 3, you're gonna go out and make a right to go to gate 2. And if you're gate 1, you're gonna go out and make a left. And they provide dinner, and dinner starts at 6, and that's when we do our program. The foundation does, I'm trying to think of the right word. If you need a vegan or a vegetarian meal, they'll provide one for you. So they're dietary conscious, I guess is the right word. So.
Next slide. Thanks, man. Oh. Well, I guess this is you again.
Oh, okay. So the Starry Night Roundup, which was scheduled for next Saturday, the 28th, we're going to postpone to either the last weekend in December or the first weekend in January, so we can properly plan. I've been talking with Bruce about some of the logistical things, and just want to get things a little more organized. And most importantly, we want to have the binoscopes working, and we want to have the Noble working. So I want to have plenty of time to get that done. The Cross Plains Volunteer Fire Department is agreed to come out and provide EMTs for us. And I haven't got the official word, but the Eastern County Sheriff's Department will have 1 or 2 deputies out there. So we're hoping to have a lot of folk out there, folks from the local high schools and local communities. So, yeah.
Okay, so you're thinking about December sometime?
December, yeah.
As a reschedule to this, yes.
Yeah, so
Okay,
something right around school break.
Cool.
Cooler,
Yeah. Doesn't
darker
overlap with
nights,
1687.
earlier nights, that kind of stuff.
Cool, thank you. All right. Monthly reports, Michelle? You got anything for the Rising Star?
I think that everybody has seen the email that Bruce sent out. I think that everyone has seen the email that Bruce sent out where we do have everything out of the storage area, and it is in the container at Rising Star, and they have the ventilation system being delivered this week, and at some point in the near future, that will be installed in a large container for that purpose.
Next week we'll install.
Apparently, it's next week they're going to install it. So. What, the ventilation system?
We did the lawn care container. So. We're gonna do the 40-footer next week.
Sorry?
We're gonna do the 40-footer next week. We've already done the lawn care container.
We're not having someone else?
Nope.
Because at some point in time, the phone's almost, okay. Thanks.
All right, next slide. Tom, you got anything for PPMSP?
It's still scheduled to open. Palo Pinto's still scheduled to open summer of 2025, and hopefully We'll start some star parties in that fall. So.
All right, moving along. Next slide. Is George online?
I am here, sir.
You got anything involving the website?
Nothing involving the website. I haven't. It's basically in park, waiting for the day it's converted over, and we do a final update to true it up to what current information is.
Gotcha. All right. Thank you, George.
You bet.
Next slide. Constantine.
Thank you. So last month, we reported a balance of $31,584. And as of September the 10th, we're sitting at $32,642. We've had 9 new members in the month of August, totaling $623. That's the membership fees plus the raffle monies. We did receive a donation of $250, and we have expenses totaling just over $2,000, the largest of which had to do with the directors and officers' insurance. Our current balance, as you see there, of $32,642 includes $40 in petty cash, and that's really our seed money for the raffle that we use. Let's look at the bottom half of the page. This is the Rising Star Development Fund. These funds are within and mixed in with the general funds, but we track them separately. Last month, 8/15, we reported a negative 957. Today, as of September 10th, we're sitting at 1742. That's due primarily to a $2,700 pad lease at the site. And as a reminder, we do have our first loan payment due next month, October 21st, for $810, and I believe we're targeting doing that plus some additional principal. Any questions? Thank you.
All right.
Next slide. Next slide. All right, bylaws, just an update. So by the bylaws themselves, the officers have to review them, and at our board meeting in November, we come up with some suggestions. So we'll take all the changes at that point in time, work through them, and in the spring, we'll have something to present to the board. I am going to hand over the next ones to Stephen Kennedy to talk about trademark and the D&O insurance. Stephen?
Hello. I filed a trademark application for the logo. We qualify for a trademark because we now have interstate commerce, which is people purchasing our merchandise from across state lines. And so we qualify, and the logo application has been submitted to the trademark office. And so as soon as it's assigned to a trademark examiner, the trademark examiner will review it. If they have any questions or comments, I'll be available to answer them. And then I expect in about a year, we will have a registered trademark for our logo. The second topic I'm covering is the director and officers policy. Because we have become a larger organization and we now own land and we're hosting so many star parties and we're growing and growing, statistically, it is likely that at some point there's going to be an accident of some type, and it can range from an accident at a star party. It could be an accident that occurs on our property. It could be, a catastrophic event of some type that, destroys property. It could be a number of different things, right? In such cases, I frequently have seen in my career that the officers and directors of the charity get sued with the organization because the plaintiff's lawyer believes that the organization may not have enough funds, so they sue the individuals, the officers and the directors, and they'll come up with some creative argument on why the directors and officers are responsible for some events, such as Johnny trespassing onto our property and breaking his ankle, requiring multiple surgeries, costing hundreds of thousands of dollars, and therefore we have to pay. So because that thing does happen, those kind of events do happen, D&O policies cover the officers and the directors and our outreach people, so that when they go to these star parties, if there's an accident, they'll be covered. And insurance will pay for any liability, and they'll pay for any attorney's fees if we get sued. So this is very important for this club to have. One lawsuit could put us into a very bad situation, and we don't want that. So for $2,000, we have insurance, and that will assure that we will continue to be a successful club now and in the future. Thank you very much.
And thank you. I think that's a really good move. By the way, for the record, oh, do you have a question? All right. You have a comment. Okay. Well, I'm going to give you the microphone anyway.
Moving out of the storage unit and putting all our scopes out at the cargo container is saving the club $2,400 a year. So we have an offset there. So just FYI.
Okay.
And just for clarification, the insurance was just under $1,000, not $2,000.
Oh, and for further clarification, the aforementioned near-Earth asteroid will not be a party to the catastrophic event that Mr. Kennedy was speaking of. Thank you very much. Next slide. What he was talking about. Next slide. Okay, do we have any other business?
I just want to put this out there, might even want to put it in a letter. I learned the hard way. If anybody's looking for a new notebook computer, Snapdragon processors are not compatible with Pegasus new software. I have the emails to back that up, several weeks of communication with Pegasus. It's an ARM issue with the processor, and they have no future vision of correcting the issue. So if you're going to get a notebook for astrology and you're thinking about Pegasus hardware, watch out, do not get the Snapdragon processor. The features are very inviting. That's why I got it. But anyway, High Point and Pegasus has been very cooperative in resolving this issue. High Point took back my Pegasus product, even though it extended their policy of returns. So just a note. Might even put that in the newsletter.
All right, anybody else? Any other business? All right, next slide. All right, so next month is our annual swap meet. It used to be in November, but now we're doing it in October, and it's next month, so get your gear ready. Swap meet. Oh, okay, so you bring all your hardware and stuff that you maybe want to get rid of, you know, telescopes, eyepieces, whatever, and stuff for sale. It's basically like, you know, kind of moving out the gear that you don't use. Yeah, it's a garage sale, except it's here. Yeah. So, yeah, and what I recommend is posting your goodies on the group's IO site, just to kind of give some advanced heads up on the stuff that might be here. All right. All right, next slide. Okay, so right after the meeting here is a lot of us gather at Social House, and I'll be there drinking beer. So anybody else want to join us, feel welcome. And next slide. That's it. Yeah. So motion to end the meeting. All right. Have a good night, everybody. And don't forget to look up at the moon tonight, because